Evaluating trigonometric functions. Example number 1. Evaluate the 6 trigonometric functions of the angle theta. This figure shows you the location of our theta. We have the hypotenuse, so whichever is the opposite of our theta will be the opposite side, and the other side will be adjacent. That means the opposite side will be 12 and the adjacent side will be equal to 5. The hypotenuse here is missing. We don't have the value of our hypotenuse, so we will apply the Pythagorean theorem to find the value of our hypotenuse. And Pythagorean theorem states that c square is equal to a square plus b square, or c is equal to the square root of a square plus b square. Applying your Pythagorean theorem, we have hypotenuse is equal to square root of 5 square plus 12 square. 5 square is 25 and 12 square is 144. If you add 24 and 144, that is equal to square root of 169. Get the square root of 169, that is equal to 13, which means the value of our hypotenuse is equal to 13. We will identify the 6 trigonometric functions of the angle theta. We will use the values of the adjacent, which is equal to 5, our opposite, which is equal to 12, and the hypotenuse, which is equal to 13. So sine theta will be equal to the opposite of our hypotenuse, which is 12 over 13. The reciprocal is cosecant theta, which is hypotenuse over opposite. Just get the reciprocal, that is 13 over 12. For cosine theta, and cosine theta will be adjacent over hypotenuse. And adjacent over hypotenuse is 5 over 13. The reciprocal of cosine theta will be secant theta. That is hypotenuse over adjacent, which is equal to 13 over 5. We have tangent theta, which is opposite over adjacent, that is equal to 12 over 5. The reciprocal is cotangent theta, which is equal to adjacent over opposite, which is 5 over 12. So these are the 6 trigonometric functions of the angle theta. Example number 2. We do have 4 and 7 as the given sides. We don't have any adjacent side here. This is the given theta. 4 is the opposite, and 7 will be the hypotenuse. Again, we will apply our Pythagorean theorem, which is equal to c square is equal to a square plus b square. The given c is, or hypotenuse is 7. So we get 7 square is equal to 4 square plus b square. We will find the value of our adjacent. That will be b square is equal to 7 square minus 4 square. B square now is equal to 49 minus 16. B square is equal to 33. Extract both sides of our equation. B is equal to square root of 33, which means the value of our adjacent side is equal to square root of 33. After we get the value of our missing side, we now identify the other five trigonometric functions. The first given is sine is equal to 4 over 7. Our sine theta is 4 over, the value of sine theta is 4 over 7. So we have opposite is 4, hypotenuse is 7, and our adjacent is equal to square root of 33. Just get the reciprocal of cos of sine theta, that is the secant theta, 7 over 4. Next, we have cosecant theta, adjacent, square root of 33 over hypotenuse, 7. Next, get the reciprocal of cosecant theta, that is secant theta, hypotenuse, 7, all over adjacent, square root of 33. Now, our fraction has a radical expression in the denominator. So what will we do is to rationalize our fraction. We multiply the numerator and denominator by square root of 33. So 7 times square root of 33 all over square root of 33 times square root of 33. And then let's rationalize. That will be equal to 7 square root of 33 over all over 33. So this is now the value of our secant theta. Next, let's get tangent theta. Opposite is 4. All over our adjacent is square root of 33. Again, we need to rationalize. We multiply both our numerator and denominator by square root of 33. And that is equal to 4 square root of 33 all over 33. And then find cotangent theta by getting the reciprocal. We have adjacent, which is square root of 33 all over the opposite, all over 4. So these are all the values of our 6 trigonometric functions.